Okay, Math 20-1 students, we are going to look at the last lesson of our rationals unit. So we're going to look at how do we solve rational equations. This one is on page 417 in your workbook. There is a little bit that we're going to skip in this lesson. What I just want us to focus on is how do we solve rational equations by the one of two methods. So we're going to do one method where we just simply cross multiply, and we're going to do one method where we have to multiply by the lowest common denominator. So on this first page, they teach us and they show us how do we solve rational equations using a graphing calculator. I'm not going to worry about this because this is a great way to double check your answers. So if you wanted to know how do you use the graphing calculator, feel free to look at the solution manual to figure out how they did these. This is just simply by finding intersection points. Okay, I'm more worried about how do we do the algebraic process. So we're going to flip to the next page and look at how do we solve simple rational equations algebraically. So we're focusing just on the simple ones because once you get to the 30 level, we'll worry about more complex questions. So it says the following strategies should be considered when solving rational equations algebraically. So I'm going to start number one here. Okay, this one's important. It says if the equation consists of a single rational expression on each side, use cross multiplication to simplify the equation. So that's my one strategy, is to just cross multiply. The second one, it says if the rational equation has more than one term on either side, consider multiplying each term in the equation by the lowest common denominator, so the LCD. That's our second strategy. Okay, and then with either strategy, we're always going to have to come up with a linear or a quadratic equation, and we're just going to focus on solving a linear equation. Okay, but we also have to make sure, as in point 4 here, is you always have to pay attention to your non-permissible values. So remember, there's going to be restrictions. So if your solution is one of your non-permissible values, it won't be considered a solution. So we have to pay attention to our non-permissible values. Okay, so I'm going to pick and choose which examples we're going to look through. We're going to look at example number 1. It says in each case, state the non-permissible value and then solve the equation algebraically and verify the solution. So we're not going to worry about example A. We're not going to get a question like that. This one B, though, we definitely will, and we'll definitely see this in Math 30-2. So we have 5 over x plus 1 equals 2 over x plus 1. I simply have one term on each side of the equal sign. So when this happens, we can use our cross multiplying method. So we're simply just going to cross multiply to solve for our variable, which is x. Okay, so step number 1, make sure to factor if it needs to be factored. I don't have to factor here. Step number 2, we're going to state our non-permissible values. So my NPVs, what are the restrictions? Because these will be important once we get our solution. So x cannot be equal to -2, as well as it cannot be equal to -1. So we'll come back to these again at the end once we find our solution. So now, because there's just one fraction on each side of the equal sign, I can simply just cross multiply. So when I cross multiply, we're going to get 5 times x plus 2 equals 2 times x plus 1. What I want you to notice here, you guys, is notice that there are no denominators. So that is a really important step because we cannot solve for x until we've eliminated the denominators. And that's our whole goal here. So that's why we've cross-multiplied, so we can get rid of the denominators. Okay, so now once we've gotten rid of the denominators, let's just distribute that 5 and 2 and see what kind of an equation do we come up with. So I'm going to distribute the 5 into the brackets, and I'm going to distribute the 2 into the brackets. So we're going to have 5x plus 10 is equal to 2x plus 2. So remember when I said notice to see what type of an equation you made? You want to look at the degree. So if I look at this line here, look at my x's. What are the degrees of these x's? It's just a degree 1. So this is just going to be a linear equation. When you get to the 30 level, you're going to see rational equations when we solve them where you're maybe going to create a quadratic equation. Now that didn't really write out very well. Let's try that again. So this is going to be a linear equation. So a linear equation, sorry, that's not really working very well, but I'm just going to leave it. A linear equation is the easiest equation to solve because all you have to do are group the x's together and group the constants together. So to solve this, I'm going to subtract 2x from both sides. And let's bring the 10 over to the right. So I'll subtract 10 from both sides. So we're going to be left with 3x is equal to 2 minus 10 is just negative 8. Okay, and then how do you solve for x? You just have to divide both sides by 3. Remember, we always leave our answer as an exact solution. So can I divide negative 8 divided by 3? I can't. So my final answer would just be negative 8 divided by 3. Oh my goodness, you guys, I apologize. Something is going on with my smartboard. So this is x equals negative 8 divided by 3. So that would be my solution. But remember, you have to double check. Okay, so double check that this is not a restriction. Is negative 8 over 3 a restriction? It isn't. Okay, so that I know is going to be a solution. And then they simply want us to just verify our solution. Okay, this shouldn't be new to us. We verified lots when we were doing radical equations. So remember, to verify, you just need to plug your solution into the original equation. So my original equation was, I think that was a 5 over x plus 1. So we're going to have 5 over x plus 1 equals 2 over x plus 2. So substitute negative 8 over 3 for our x. So this is going to be written as 5 divided by, I have negative 8 over 3 plus 1 equals 2 over negative 8 over 3 plus 2. Okay, you simply just need to take your calculators and plug these numbers in and make sure that we get the same result. So when I plug all of this into my calculator, I get negative 3 is equal to negative 3. So does your left side equal the right side? It does. So I give myself a little check mark and I say the left side is equal to the right side. So we know for sure negative 8 over 3 is a solution. Okay, so this is our first method of solving a rational equation. We just simply cross multiply. So let's do one more example like this. If we go to the next page, we're going to look at example 2a. So it says state the non-permissible value and solve the equation algebraically. So if I look at a, I know that there's just one term on each side of the equal sign, so I can simply just cross multiply. But this question gives us a little bit more work because I'm going to need to factor first. So always factor first. So in my first fraction, I can take out a 2. So I'm going to be left with 2 times, this is going to be x minus 1, divided by, I can take out the, I cannot take out a 2. So I'm going to be left with just 2x plus 3 is equal to, in this numerator, I can't take anything out, so this is just going to stay as 6x minus 1 divided by, I can't take anything out of this denominator, so I'm left with just 3x plus 5. Okay, we're not going to do b, so you can cross that out and use the whole space to do your solution. Now that I've factored, I have to make sure that I state my non-permissible values. So state my NPVs. I know x cannot be equal to negative 3 over 2, and x cannot be equal to negative 5 over 3. So again, we're going to double check our answer with our restrictions at the end. Okay, all we have to do is simply just cross multiply. So now when I cross multiply, I'm going to have 2 times x minus 1 times 3x plus 5 equals 6x minus 1 times 2x plus 3. Now, unfortunately, we did that factoring at the beginning of the question, but it really didn't do us any good because we're going to end up having to FOIL. So I'm just going to put this 2x, or this 2 back into the bracket. So this is going to be 2x minus, oh, and actually, guys, when I factored it, I didn't even factor it correctly. So this should have been 2 times 2x minus 1. So again, this is going to be 4x minus 2, because I'm going to have to FOIL, so there was no point in factoring that. Okay, so now I have to FOIL everything on the left and FOIL everything on the right. So when I FOIL on the left-hand side, I'm going to have 12x squared plus 14x minus 10 equals, this is going to be 12x squared plus 16x minus 3. Okay, so now I notice that I have some x squareds in this one. What do you notice about the x squareds though? They're both 12x squared. So no matter what, when I move one of them to the other side, they're actually going to cancel out. So I can just right away cancel out the 12x squareds. Now I'm left with the 14x minus 10 and the 16x minus 3. This is a linear equation, so we want to group the x's together and the constants together. So I'm going to subtract 14x from both sides, and then we'll bring the 3 to the left, so I'll add 3 to both sides. So negative 10 plus 3 is simply negative 7 equals, and 16x minus 14x is just 2x. And then to solve for x, all I have to do to both sides is I would divide both sides by 2. Okay, can I divide negative 7 divided by 2? I can't. So I would just keep my answer as x equals negative 7 over 2. Okay, again, double check, is this a non-permissible value? It isn't, so I know that my answer is correct. Okay, and then one thing we must always do is verify. Okay, so to verify again, take the original equation and just plug your answer in. So to do that, we're going to have, so I'm going to write my verify work here. So I'm going to verify 4 times negative 7 over 2 minus 2, all divided by 2 times negative 7 over 2 plus 3 is equal to, this is going to become negative 16 divided by negative 4, which equals 4. So this is going to be, that's going to be my left-hand side. Okay, so this was the left-hand side. Now let's figure out what was on the right-hand side. And I'm just doing it separately like this just because the work would be kind of messy, just writing it all at once. So then we're going to have 6 times negative 7 over 2 minus 1, all divided by 3 times negative 7 over 2 plus 5. Again, when I plug all this into my calculator, I get negative 22 divided by negative 11 over 2. And so this simply equals 4. So we notice that 4 and 4 are equal, so left side is equal to the right side. So my solution is going to work. Okay, so when we're solving a rational equation, you guys, whichever method you use, it doesn't matter, but you have to make sure that you always verify your solution at the end. And remember, you do get marks just for the verification. Okay, so that is the first method of solving, which is to solve by finding, just by cross-multiplying, sorry. And so now we're going to solve by multiplying by the lowest common denominator. So I have used up this whole page, so I'm going to have to just erase this bottom part, and we're going to look at example 3, because this is the second strategy that we have to use. Okay, so example 3 says, solve the equation 1 divided by x minus 4 plus 2 divided by x plus 4 equals 5 divided by x squared minus 16. So if you notice in this equation, I have more than one term on one of the sides. So on this left-hand side, there are two terms. And then on the right-hand side, there's only one term. Because I have more than one term on that one side, we cannot use cross multiplication. So to solve this, we must multiply by the LCD. This is the second method. Okay, so just like the title says, multiply by the LCD, we need to find the lowest common denominator amongst all three terms first. So remember, we have to factor first, and I can factor that x squared minus 16. So this is going to be written as 1 over x minus 4 plus 2 over x plus 4 equals, this is 5 divided by x plus 4 times x minus 4. Okay, now that everything's factored, state your non-permissible values first. So my NPVs are going to be x cannot be equal to, this is plus or minus 4. So I have two non-permissible values. Now we're going to have to multiply by the lowest common denominator. So remember, what is our lowest common denominator? Okay, take a look at our factors. My first fraction, I just have x minus 4. My second fraction, I just have x plus 4. But in my third fraction, I have both x plus 4 and x minus 4. So I need to have at least both of those. So this is going to be x plus 4 times x minus 4. Now, this is where students sometimes make a mistake. When solving a rational equation, they think it's like adding or subtracting, where you have to figure out what you have to multiply one fraction by to get the LCD, but it's not. Think of the title. It says multiply by the LCD. So what you want to do is multiply every single fraction by that lowest common denominator. So I'm going to multiply this first one by x plus 4 times x minus 4. Okay, we're going to multiply the second fraction by x plus 4 times x minus 4. And we multiply the third one by x plus 4 times x minus 4. Make sure you write this out. Now, do not FOIL or distribute anything until you cancel out the denominators. So go back to this first fraction and think, what can you cancel out? Well, I can cancel out x minus 4 on the bottom and x minus 4 on the top. In the second fraction, I can cancel out x plus 4 on the bottom and x plus 4 on the top. And in the third fraction, I can cancel out both x plus 4 and x minus 4 on the bottom and x plus 4 and x minus 4 on the top. The whole point of doing this was to get rid of the denominators. So now write what you're left with. I'm left with 1 times x plus 4, and then plus 2 times x minus 4 equals just 5. Okay, this line is really important. You want to get here, just like we did when we cross-multiplied, you got rid of the denominators. So now all we have to do is distribute into our brackets and simply solve. So 1 times x plus 4 is going to be x plus 4 plus, this is 2x minus 8 equals 5. Okay, so what type of an equation is this? Again, this is just simply a linear equation. So we're going to collect like terms. So I'm going to have 3x, and then this is simply minus 4 equals 5. Okay, how do I solve for x? I'm going to add 4 to both sides. So I'm left with 3x equals 9. Now what do I have left to do to both sides? I simply just need to divide by 3. So x would be equal to 3. Okay, and then make sure you double check. Was this a non-permissible value? It wasn't. Okay, so just check. It wasn't, so this solution should work. But what do we still have to do just to complete this question? We have to make sure that we verify. Okay, so remember, to verify, just simply plug your solution into the original equation. So we're going to have 1 divided by, this would be 3 minus 4, plus 2 divided by 3 plus 4 is equal to 5 divided by 3 squared minus 16. Okay, and we can have our calculator do most of this. So 3 minus 4 is negative 1. So this is going to be 1 divided by negative 1 is negative 1. Plus, this is going to be 2 over 7 is equal to 5 divided by 9 minus 16. So just plug into your calculator what's negative 1 plus 2 over 7. We're going to be left with negative 5 over 7 equals, and this also results into negative 5 over 7. So we know left side is equal to the right side. So my solution of x equals 3 is going to count. Okay, so this second method, this second strategy is definitely a little bit more work. Okay, but just think your main goal is to always get rid of the denominators, and then you just simply have to solve your linear equation to solve. Okay, so that wraps up our rationals unit. Make sure that you do the homework questions from this lesson. Make sure you're practicing by cross-multiplying, and make sure you're practicing by multiplying by the LCD. All right, and then you're going to practice the practice test for rationals and get a few more review questions, and you should be prepared for our rationals exam. Okay, next week we are going to start our next unit, which is trigonometry. Okay, thanks you guys. Have a good day.